All right, welcome to part 2 of the vaulting tutorial. We're just going to continue right where we left off. So let's go ahead and start filling out this can vault function. So let's double click on it to open it up. So inside of here, the first thing we want to do is we want to make sure that we are in a current state where we can actually vault. So let's drag this guy in, and then we'll say equals, and then make sure you select the enum equals so that we can actually select from this drop down. So we want to say equals not vaulting, and then we'll do a branch. So the reason we're doing this is because we obviously don't want this function to return true if we're already in the middle of a vault. So if we're not vaulting, then we want to continue. Otherwise, we can just drag and hook this false up, and then we want to make sure that we uncheck result here because we want to return false. And then for the ending location, we can also just leave this empty because if it's returning false, meaning that we can't vault, then there is no ending location. So we're just going to go ahead and leave that as 0, 0, 0, which is fine. Okay, but assuming that we are in a position or in a state that we can vault, we want to start doing the vaulting code. So the first thing we're going to do is we're going to drag our character in, and we're going to get his capsule component because that's what's used for the collision. So we'll say get capsule component. And then we want to just cache this to make it a little bit easier. So actually, I'm just going to right click on this and say promote to local variable. And that will give us a local variable. If you don't know what local variables are, they're basically the same as normal variables, except they're local to this function. So if you're not inside of this function, then it will go away, or you won't have access to it. And each time the function is called, the local variable is reset. So it's not like it persists between functions calls. It's more of just a local variable that gets created when the function is invoked and then gets destroyed when the function gets destroyed. So we will just call this capsule. And then I like to put in parentheses local, just so I know it's a local variable when I'm looking at it, like so. And then basically what we want to do is we want to do a line trace from in front of the player down into the world. So I can just draw this real quick to kind of give you guys a better idea of what I'm talking about. It'll just take a quick second. So if your player is here, just bear with me here while I do some stick art. So here's your player. And let's say, so this is his mouth, so he's facing to the right. I don't know why I keep creating these things. So let's say you have a little box right here. So what we want to do is we want to do a line trace from somewhere in front of the player down into the world. So we want to do a line trace like right in this direction, right? Like down into the world. So it's going down. And we want to know where it collides with something. So obviously it collides right here, right? So this is the first step. So the first step is going to be creating this line trace. So let's right click and say line trace by channel. So we need to figure out the starting location and the ending location. So the starting location is basically, like you can see, it's going to be the location of the player, which is going to be right here, his origin. This is the location of the player. And then we want to go plus some amount of units forward and then up some amount of units so that we get up here. So to do that, we can say owning player, get actor location, and then we want to say vector plus, and we want to add in his forward vector. So we'll say get actor forward vector, if I can type. So that's the direction he's facing. And then we want to do it times some sort of amount. So we'll say float times, and then I'm just going to use 70. You can kind of use whatever number you want here, whatever number feels good to you. But basically what that number is this distance here. It's this distance. So like how far in front of the player do you want this line trace to be? And you don't want it to be too far away, otherwise he'll be able to vault like way too far in front of him and it won't be very accurate. So you just want it to be just kind of barely in front of him. So we'll use 70. And then we want to take that value and say that that is, well, that's almost our start position, right? Because that gets us to here. That gets us to like this general area. Oops, that wasn't a circle. That gets us to this area right here, but we want to go up because we want to go to here. So we want to say another plus. So we'll say vector plus. And we only want to affect the z. So I'm going to go ahead and split this because we only want to add to the z, which is the up. And so the amount that we want to add is basically going to be the half height of his capsule because we want to add basically half of the character's height so that we get up to here. So we'll say capsule component, get scaled half height. So this is basically the half height of the character. And we want to hook that up to the Z. And then that's going to be our starting location. And then our ending location is going to be basically the same thing, except um, instead of adding to the Z, we want to subtract to the Z. So we'll say vector minus vector. And then we will hook this up. And then we're going to go ahead and split. And then we'll hook the Z up to the Z again and hook that up to the end result. Okay, so that's our starting and our endpoint. The next thing we need to select here is we want to make sure that we ignore the player or our owning character. So we can drag in our owning character and hook that up. And that's just to make sure that the line trace doesn't hit the character, because obviously we don't care if the line trace hits the character because he can't collide with himself anyways. And then we can go ahead and draw this. So we'll just switch this to 4:1 frames since it's running on tick basically. And we can go ahead and see what this looks like. So let's hit play, and you can see, I don't know if you can see it on the tutorial because it's really thin, but there's a red line in front of me. Yeah, I guess you can see it. And when I go up and I walk next to something, you can see it hits the top of the object. And so this is the line trace, and you can see it's in the right spot. If you don't see this line, then go back and make sure you did that correctly. All right, so that's working well. The next thing we want to do is we want to check if it actually hits something. So we'll drag off this and say a branch. So in the case that the line did not hit something, then that means that we're either on like a totally flat surface, or maybe we're at the edge of a cliff, and so the line trace isn't hitting anything. But either way, we just want to go ahead and return false because obviously there's nothing in front of us that we can vault. So I'm just going to go over here and copy this return node. So Control C, Control V, so paste it, and we just want to return false. But in the case that we did hit something, then what we want to do is figure out if that location that we hit is a valid location to vault to. And so to check that, we're going to make a handy little function over here. And just to kind of keep things more organized, we'll call it can vault to hit. And the reason it's called to hit is because we're going to pass in this hit result. So let's take this can vault to hit, and we will make it private, and we'll add it to a private category. And we really want to make sure we do this because we don't want somebody else calling this function, because it'd be kind of weird, because like they really shouldn't. We only want them to ever be calling this function from outside. So make sure you make this private so that other people don't have access to it. And so let's open this guy up, and we need to add some input parameters. So the first input parameter we want to add is for the capsule, because we're going to need access to the player's capsule. So I believe the type for that is just called capsule collision, and then we want object reference. We'll just go ahead and call that capsule. And then the next thing we want is a hit result. So hit result, and we will just call this hit. And then we also want to output some parameters as well. So we want to output the result for whether or not it's a valid location that we can vault to. And then we also want to output the ending location. So add a Boolean parameter, and we'll just call it result. And then we also want to add another one and make it a vector and call it ending location, which is the location that he's going to end up if he were to vault. Okay, so this function is going to be a little large, but it's going to be broken down into 3 main sections, because there's basically 3 checks we want to do. We want to first check if the ledge that we're trying to vault to is an appropriate height, meaning like it's not too low or not too high. So we want to make sure that's okay. And then we also want to make sure that the surface that we're trying to vault to is walkable. And what I mean by that is that it's not, it's not too steep, right? So like the place we're trying to vault to is, not too steep, so we can actually walk on it. And then we also want to check that there's room enough for us that if we were to vault on top of the ledge, that we can actually stand there. So those are the 3 things we want to check. So I'm just going to actually unhook this for right now and move it right here because we're going to come back later. And we're going to add a sequence node. So you can hold down S on the keyboard and left click. It will create a sequence node. You can also do this by just searching for a sequence, if I can type, and it will show up. So we actually want 4 of these guys. So we want a then 0, 1 through 3. So create some of those. And then for the then 3, we're going to hook this guy up and we're going to return true. So And we're also going to return the ending location. So if we right click on this, we want to promote it to a local variable, and we will call it ending location local. Okay, so let me just explain what's going to happen here because it might be a little confusing right now. But the way we're setting this function up is that it's going to do those 3 checks off of these thens. That's kind of complicated, off of these thens, but off of these nodes, it's going to do those 3 checks that I just talked about. And if any of these checks fail, they're going to return false. So if they return false, it's never going to get here. So the idea is going to do those 3 checks, and if they all succeed, meaning they don't all return false, or none of them return false, it's going to finally get down to here, and then it's going to return true. So that's kind of the way it's structured. So we just need to go ahead and write each one of those checks. So we'll kind of go in order here. So the first one I said is that we need to make sure that the ledge is the appropriate height. So to do that, we can use this hit result. So if we just right click and say get hit, we can get access to this hit variable. And then we want to take this node and we want to right click and say split struct pin, and that will split it up into all the different available information for us. We kind of want to drag this up here because we're going to need a little bit of room. So we want to check the height of the thing. So to do that, we can get the hit location and we can say break vector. And then we also want to get the end location of our trace, and we want to break that. And then if we subtract these values, it will give us the height of the thing that it hit relative to like our feet, basically. So we can say float minus, like so. And then we can just go ahead and print this out just so you can kind of see what I'm talking about here. That'll make a little bit more sense. So we do a print string, and then we can drag this guy into there. Then we need to hook this up. So I'm going to take this then 0 and drag it all the way up here. I know it looks like I'm kind of going crazy off to the side here, but we're going to need a lot of room, so you'll kind of see what I'm doing. And then I'm going to make a little reroute node here and drag it up just so it's nice and straight here. Okay, so that's our height. And so what we want to do is we want to take this height value. So let's change this to 0 as well so it doesn't spam. We can make it like green or something for our height value. So what we want to do here is we want to take this value and we want to make sure that it's within a certain range, right? So we want to make sure that it's not too low. And we also want to make sure that it's not too high. So we'll say float in range. And then these ranges here are basically whatever you want to configure them to. So we're going to make them variables, and that way you guys can set them to whatever you want really easily. So we're going to promote to variable, and we will call this, instead of min, we'll call it the min vaulting height. And then we want to take this and we want to move it into the private category as well. And we want to mark it as private. Except for this one, we also want to make it blueprint read only because this is actually going to be a constant variable because it's not something that's changing when the game's running. It's just something we set at the beginning. And whenever I make something blueprint read only, I like to add it to a constant category. So if you hold down shift and then hit the not backspace, but backslash, it's the button below the backspace button, it'll make like a vertical pipe. And that's how you add subcategories. And then we're just going to call this constants. So when I do that, you'll see on the left here, it's added a constants category under the privates category. So it's private, but it's also constant. And then we want to just duplicate this guy and call it max vaulting height and hook this up as well. Okay, so if we compile this now, we can set these values. So the values that I have them set to, again, feel free to adjust them if you want to, but I used 50 for the min, and then for the max, I used 170, like so. And so we're checking if it's in that range, and then we're going to do a branch. Oh, I just realized our ending location is not private, so this should be private as well. So drag the ending location into private, and then set it to private as well. I forgot to do that. Okay, so we're doing a branch. And so again, what this branch is checking is if the height of the ledge is not too high and it's not too low. And so we actually want to check if it's not the case. So we'll say not Boolean, and we'll hook that up instead. Because if it's not in that range, that means that it's not a valid ledge for us to grab, and we want to go ahead and return false. So I'm going to come over here and copy this return node, and then come back over here and hook it up to the true. And then we want to make sure, be very sure that you unhook or you uncheck this result, because again, we want to return false if we're not within that range. And we want to return false because If we return false there, then it won't come down here and return true later. Okay, so that's the first check. So we can add a little comment around this. If you just highlight everything and select C, it will add a comment. And so what this is checking is, make sure that the ledge is at an appropriate height, right? So this is making sure that the ledge is at an appropriate height or a valid height for us to actually vault up on. Okay, so we can go ahead and run this so you can kind of see what's going on. But actually, before we do that, let's add in some boxes so we can kind of see what's happening here. So I'm just going to drag in a cube, and then I'm going to set the scale of the cube to like 2 by 2, and then I'm going to drag it up and then press end on the keyboard, and that will ground clamp it. So if we run this and we walk up to the cube here, oh, why is it not? Maybe I did not hook something up quite correctly. Let's come back here. Are we actually calling this function? Maybe we're not actually calling this. Let's go back to can vault. Oh, right. Okay, so we're not actually calling this function. So all we need to do is, so after this line trace, if it actually hits something, we want to drag in can vault to hit, and then hook this up. And so for the hit, we want to hook up our hit from our line trace. And then for the capsule, we want to hook up our local capsule. Okay, so let's give this a try now. And again, I know it's not finished yet, but I just want to show you this number that prints up at the top left. So you can see if I'm not next to any ledges, like nothing prints up or prints out. But if I walk up close to a ledge, you can see it prints out, in this case, 97.978, right? So that's basically the height of this box. So to kind of show you a better example here, if I make another box and I set the height to like, or if I set the scale to like 0.5, and then clamp it down to the ground. So if I walk up to this box, I'm trying to get right next to it, you can see the height is 47.9, whereas this one's 97.9. So it tells you basically the height of the thing, and we can use that value to determine whether or not it's a valid height, right? Which we already kind of are. But I just wanted to print that out to make sure that you guys kind of understood what was going on, and also make sure that that number appears the same on your, on your screen, right? Because if it doesn't, then you might have messed up the math somewhere. So that's basically what that is. So let's come back in here and kind of finish this up. So we got this first check done. So the next check we need to do is we want to make sure that the ledge has a walkable surface, right? So I'll just kind of show you what I mean actually real quick. So for example, if we have another box here, so I'm just going to alt drag to make a copy. If we have a box here and let's say it's rotated like, 60 degrees. So currently, if we go up to this, you can see it's printing out, in this case, it's printing out like 80, oops. So it's printing out 90 right here, right? And so the current system would say, yeah, this is a valid thing to clamber on or to vault up on because 90 is between our min and our max range. But we don't want to actually be able to vault on this because like we can't even stand on this. So it wouldn't make any sense to vault up on it. So we need to check the slope of this thing. So if we come back here to our vaulting component, that's what we're going to do next. So again, we're just going to copy this guy. So we'll say copy paste. And we want to take the hit normal and we want to break it. And we want to look at this Z value because there's actually a value inside of the character movement component that tells you what the max walkable floor Z value is. So we can get our owning character, and then we can get our character movement component. So I think you can do that by just saying get character movement, which is down here. And then we want to say get walkable floor Z. And make sure you get walkable floor Z and not get walkable floor angle because it's not the same thing. So we want to get the walkable floor Z, and if you hover over this, it tells you what it does. So it says gets the Z component of the normal of the steepest walkable surface for the character. Any lower than this, and it should not be walkable. So what that means is that we can say, okay, if this is less than that, so we'll say float less. If it's less than that value, then we want to go ahead and just return false because it's too steep. So we can do a branch. And then we're going to hook this up to the then one, something like that. And then again, I'm just going to copy this return node and paste it. And make sure, again, that result is left unchecked. Okay, so Actually, let's actually print out. Let's go back to our event graph here, or sorry, let's go back to our can vault, and let's actually print out. Let's do a print string here and print out the results so we can see it actually working. And then let's set this to 0, and then let's run this. So you can see it's printing out true at the top left, and that's saying like true we can vault. But if we go up to this one, it's going to say false because it's actually too low. It's below 50 or 60 or whatever we set it to. And so it's not going to allow us to vault. And if we try this one now, and you can see the number is 98, which is a valid height, right? It's within that range, but it's still printing out false. And the reason it's printing out false is because of that code we just added. It's detecting that it's too steep, so it's still saying false, and it's still not allowing us to vault, right? Okay. Maybe we can go back and hook up our. Let's go back to can vault real quick. And let's maybe finish this function real fast. I know I'm kind of going back and forth, but I'm just trying to kind of show you guys what's going on as we're doing it. So let's just add, where's the return node? Yeah, so let's just copy this guy and put it here after the print string. And then let's return the result. We can leave this print string here. And then let's also return the ending location. Like so. So now if we play it, you can see that the widget, the space to vault widget pops up when it's actually a valid thing for us to vault on, right? So you can see it doesn't pop up here, but it pops up here, doesn't pop up here. So that's good. Maybe we can just get rid of this print string because we can kind of tell if it's succeeding based on if the widget pops up. So we can maybe just delete that. Okay, so let's go back here, and we have one more thing to do inside of here, and that is making sure that we have enough room to actually, like make sure that the ledge has enough room for us, right? So to do that, actually, let's make a little comment around this guy first of all. We will say, make sure the surface we're vaulting to is walkable. Okay, and then the final thing we want to do here is make sure we fit. So again, I'm going to copy this guy, paste it down here. So to do this, we want to look at the location where the line hit, and we basically want to put a capsule there and then check collision on that capsule and see if that capsule hits anything. So we can take this hit location and we want to say vector plus, because we need to add the half height to the capsule to it so that it's not, so that the capsule's on top of the surface and not in the middle of it. And then we can say, where is our capsule? Oh, our capsule is a parameter. So we can just right click and say get capsule. And we want to get the half height. So we'll say get scaled half height. And we want to add that to the Z. So we're going to split this guy and add that into the Z like so. And we want to save this as a local variable. So, oh, we already have a local variable. When did I create that? I don't actually remember doing that. Oh, we created it here, right? Okay. So yeah, we want to save our ending location, our local ending location. Make sure you select the local one and not the non-local one. And we want to save that. And then we're going to hook this guy up to the then 2, like so. And then from there, we want to check if this capsule at this location is colliding with anything. And it will make more sense once we start rendering it. But for now, let's just drag off of this and say vector plus. And we're actually going to add the capsule's radius to this. And we're doing that so that the capsule appears a little bit above where we're actually going to land on. And I'll explain why we do that once we have it visually showing. But for now, let's just copy this capsule and say get scaled capsule radius. And we want to add that to the Z. And then from there, we want to do a collision check. And I'm going to make a little function for this because it will make it a lot cleaner. So we're going to add a function over here on the left. And we will call this check capsule collision. And we want this to be private because we don't want anybody else calling this. So we'll drag it into the private category and then mark it as private. And so this is going to take in a few parameters. It's going to take in a vector. So add a parameter that's a vector and call it center. And this is going to be the center of the capsule. We want another one for the half height. So hit plus, and then this is going to be float. We will call it half height. And then we want one more for the radius. So add another one and call it radius. That's the radius of the capsule. And then we're going to add one more and make it a Boolean, and we will call it draw debug. So this is basically going to be a bool that tells it whether or not it should draw a debug capsule, which is going to be really helpful for visualizing it. So if we come inside of here, this function is going to be pretty straightforward. We want to start out with a sequence node. So again, hold down S, left click to create a sequence. And then the first thing we want to do is we want to check if this draw debug is set to true. So if we compile this and then right click and say git draw debug, we can get access to that. You can always just drag off of it, but I prefer to just get another reference to it because it's a little bit cleaner. And then we can go branch. So if draw debug is set to true, then we just want to draw a debug capsule so we can visualize what's going on. So we'll say draw debug capsule. And the center location is, well, so these parameters are basically going to be these parameters. So we can say get center, and then get half height, and get radius. And then the duration, we can just leave as 0. Maybe we'll change this to like a yellow color or something. And then the thickness, we'll set it to like 3. Okay, so that's going to draw the debug capsule if it's enabled. And then the next thing we want to do is we actually want to do the capsule collision itself. So we'll say right click and say capsule overlap actors and hook that up to the then 1. And then again, we just want to use these values. So I'm just going to copy and paste and then hook them up. But make sure that, because these are switched, I don't know why, but like radius is above half height here where it's below it over here. So make sure you don't get these mixed up. Make sure you have radius going into radius and half height going into half height. For the object types, we need to drag up this and say make array. So basically what this is saying is it's asking you for all the different object types you want to count for the collision. So you probably want to select like most of these or all of these. So we definitely want world static, and then we also definitely want world dynamic. We might maybe want to ignore pawn, like maybe you don't care if there's already a player up there. So maybe we can leave that one off. Definitely physics body. Vehicle, yes, definitely want to collide with vehicles. Destructible objects. And I think that's it, because I don't really care about projectiles. So that's probably good. The class filter, we can just select actor because we want it to check against everything. And then the actors to ignore, we want to ignore ourselves again. So we'll drag in the owning character and hook that up. And when you do that, it will automatically make an array for you. So let's scoot this over a little bit just to kind of clean it up. So yeah, that's basically what it should look like. So this is really the important part. This is really the part that's checking whether or not we're going to fit. And so we want to return this value. So if you just, we need a return node. We don't have a return node. No, we don't. So we can just add an output parameter, and that will give us a return node, and make sure we have it a Boolean. And we just want to set this to result. And then we can drag this down here and hook this up. So as you can see here, all this function is doing is it's first drawing the debug capsule if we've told it to, if we have draw debug set to true. And then it's just doing a really simple collision check to see if any actors overlap with the capsule that's being passed in, and then it returns that value. Okay, so now if we come back here to our can vault to hit, where was I on my other monitor? Hold on. Right, okay, so we can call this function. So we can say check capsule collision. And we want to make sure we hook this up. So hook that up. And then the center is going to be this. The half height and the radius are going to come from our capsule. So we can hook the radius up to here. And then we can say get scaled capsule half height and hook that up to there. And then we can do a branch. And so if this is true, then we want to return false, because if the capsule is colliding with something, that means there's no room for us on top of the ledge, so we want to return false. So again, I'm just going to copy this return node and paste it here. And again, be very sure to make sure that result is still false. Okay, so you can kind of see what's going on here. Let's also check this draw debug so we can actually draw the debug capsule. And so now if we go ahead and we play it and we walk up to a ledge, you can see it's drawing a debug capsule. and it's only drawing it if it passes the first two checks. So it's not going to draw in here because it's not passing the slope check, and it's not going to draw in here because it's not passing the height check. But it draws one here because it passes those checks. And as you can see, it does draw it a little bit above the surface. And that's what I was saying before. Like that's basically caused by us adding the radius to the location. And the reason we're doing that is because, well, there's a couple reasons. One is that we want to have a little bit of extra leniency to the height. Like we don't want to just barely be able to fit in a slot. We want to make sure the character can actually really fit. But another reason we do it is because of this case. So if we come back here and let's make another one of these. So I'm going to alt drag, and then I'm going to alt drag again to make another one. And I'm going to rotate this like 30 degrees. You don't necessarily have to do this, but actually it's probably a good idea. Make sure it still works. So this is the use case where we need this, and it's important because if we come over here, if we didn't elevate the capsule, then the capsule would actually collide with the slope, where it could potentially collide with the sloped surface because the sloped surface could potentially cut through the capsule. But if we elevate the capsule a little bit, then it's going to account for sloped surfaces, and it's going to raise it up a little bit so that even if the surface is sloped, it's not going to cut into the capsule and make it return false incorrectly, right? So that's kind of the two reasons we do that. Right, okay. So now we have that set up. We are pretty close to being done with this function. I think actually we are done with this function. Let me just zoom out. Yeah, we are. So you can clean this up a little bit with reroute nodes and make it a little bit prettier. But I kind of wanted to set it up this way so you can see how it's being broken down into these three main checks. So we'll just do this, and then we'll add another comment down here. And so this is basically make sure that there is enough room for us on top of the ledge. So again, just to kind of recap here, all this is doing is it's has a sequence here, and then it first checks to make sure that the ledge is the appropriate height. And then if any of these fails, if any of these three checks fail, it's going to return false right away. And then it checks if the surface is walkable, and then it checks if we can actually fit. And so if all three of those pass, then it's going to come down here to this thin 3, and it's going to return true, and it's also going to return the ending location, right? So, oops, just trying to file save all. Okay, so now we can come back here. Let's see where I left off. So CanVault is finished. And so now we can actually start making use of this. So if we go back to the event graph here, so I'm just trying to remember where I left off because we kind of went down a rabbit hole there for a second. Okay, so this is all good, and this is all good. Okay, so I think everything is pretty much good in terms of whether or not we can vault. The next thing we need to do is actually doing the vaulting itself, which that's actually relatively easy. The figuring out whether or not we can vault is really the hard part. So we got the hard part done. The next thing we need to do is the actual vault itself, and then the little animation that he does where he puts his gun down. So we'll go ahead and do that in part 3. So I'll see you guys in part 3.